Hi madam, I'm Yasmin and today I'm gonna present chromatography. What is chromatography? Chromatography is a laboratory method used to separate mixtures which involves moving a mixtures dissolved in a mobile phase through a stationary phase. The components of the mixture separate because they move at a different speeds depending on their interactions with the stationary phase. There are two types of chromatography that commonly used in a laboratory. First is known as planar chromatography, which is a type where the stationary phase is present on a flat surface. There are two main types of planar chromatography, which is paper chromatography and thin layer chromatography or TLC. Paper chromatography, a strip or sheet of paper serves as the stationary phase. The paper is often made of cellulose, which can absorb water or other solvents. A solvent or mixture of solvents acts as the mobile phase. Meanwhile, thin layer chromatography or TLC, a thin layer of a solid adsorbent such as silica gel, alumina or cellulose is coated into a glass, plastic or metal plate in stationary phase. A solvent or mixture of solvents serves as the mobile phase. Second is column chromatography. It is a separation based on differential absorption of substance between a stationary phase, which is solid or liquid, and mobile phase, liquid or gas, passing through a column. There are two types of column chromatography, which is absorption chromatography and partition chromatography. Next, we move to advantages and disadvantages of chromatography. First, the advantages of chromatography is high resolution and sensitivity. Chromatography can separate complex mixtures into individual components with high resolution, which is it can detect and measure even every small amounts of substance, which making it highly sensitive. Second, on versatility. It is applicable to a wide range of substances, including gases, liquids, and solids. Various types of chromatography, example gas chromatography, liquid chromatography, thin layer chromatography, can be used depending on the sample and the desired analysis. Third is on quantitative and qualitative analysis. Chromatography allows for both qualitative, which is it can identifying substance, and quantitative, which is it can measuring the amount of substance analysis. Fourth, high speed and efficiency. Some forms of chromatography, such as high-performance liquid chromatography, offer rapid analysis times, which is automated systems and advanced detectors enhance the efficiency of the process. And last, reproducibility. Chromatography techniques, especially when automated, provide consistent and reproducible results. When there are advantages, there must be disadvantages. So, the first is cost. Equipment and maintenance can be expensive, especially for advanced systems like HPLC, which is high performance liquid chromatography, and gas chromatography. Consumables such as columns, solvents, and detectors add to the operational costs. Second is complexity. Chromatography requires specialized knowledge and training to operate the equipment and interpret the results. The setup and optimization of chromatographic conditions can be complex and time-consuming. Third is on sample preparation. Some samples require extensive preparation before analysis, which it can be time-consuming and may introduce some errors. Fourth is limitations in analyzing certain compounds. Some compounds may not be easily separated or detected due to their properties, which is, for example, non-volatility, which is lack of chromophores. And last, on environmental and safety concerns. The use of organic solvents and other chemicals can pose environmental and health hazards. Proper disposal and handling of hazardous materials are necessary to ensure safety and compliance with regulations. We move to application. So, the objective of experiment chromatography is to separate the mixture. There are several theories on this experiment, which is first is stationary phase. Stationary phase is the material that stays fixed inside the column, which it can be a solid or a liquid supported on a solid. It acts as the medium through which the mobile phase moves. The compounds in the mixture interact with the stationary phase to different extents based on their chemical properties. This differential interaction causes the compounds to move through the column at different rates, leading to separation. Second is mobile phase. Mobile phase is the fluid that moves through or over the stationary phase. It can be a liquid or a gas. The mobile phase carries the mixture of compounds through the stationary phase. Compounds that interact less with the stationary phase and more with the mobile phase will move faster through this column, while those that interact more with the stationary phase will move slower. So, the interplay between the stationary and mobile phase determines the efficiency and effectiveness of the separation process in chromatography. In chromatography, partition and adsorption are two fundamental mechanisms that explain how components of a mixture are separated based on their interactions with the stationary and mobile phase. First, partition chromatography. Partition chromatography is based on the differential distribution of compounds between two immiscible phases, which is the stationary phase and the mobile phase. For methodology, we start by partially filling a glass with a solvent and covering it, which is allowing the jar to saturate with solvent vapor. Then, we draw a fine line using a pencil about 2 cm from the edge of the chromatography paper. Then, place a small drop of the mixture into the line and let it dry. Additional drops can be added to concentrate the sample at the same spot. Fourth, position the paper vertically inside the jar, which is ensuring it doesn't touch the jar's walls. Keep the spot approximately 1 cm above the solvent surface to prevent the components from dissolving into the solvent. 5. Capillary action draws the solvent up the paper, which is dissolving the components in the drop as it passes through the spot. Different intermolecular forces between the components in the paper's cellulose cause them to separate. 6. When the solvent nearly reaches the paper's end, Remove the paper from the jar and mark the solvent front. 7. Detect the positions of colorless amino acids by spraying the paper with ninhydrin, which turns most amino acids purple upon reaction. And lastly, identify the compound by comparing the spot positions with those of known substance and calculating the retention factor RF of the solvent for the solute. As for the results, we got the higher retention factor values, which is RF, is the blue color, which is 0.6822. This is mean the interaction between the blue compound of interest and the surface is strong. This is how we got the value of RF, which is retention factor formula. This is a short video on how mixture separate by the chromatography. In conclusion, the chromatography experiment successfully isolated and identified the mixture's components, producing 5 distinct peaks that match the expected retention times for compounds A, B, C, D, and E. The separation was precise and well-defined, showcasing the effectiveness of the selected mobile and stationary phases. Minor inconsistencies in the solvent front movement indicate that sample application could be improved for more consistent results. That's all, thank you.